Welcome. Today we're going to talk about properties of exponents, positive and negative exponents, zero exponents. So first, the properties of exponents. If you're multiplying two things that have the same base to a power, and you're multiplying, you do that by adding their exponents. You don't multiply the bases, you add their exponents. That's how you multiply. If you're dividing, you would subtract the top minus the bottom in general, but to make it easier on yourself, we want only positive exponents for the most part. So really, when we're doing this, if the bigger one is on top, we do this. If the bigger one's on the bottom, we would make the top a 1 and the bottom would become, the big minus small. So if n was bigger, it'd be n minus m on the bottom instead of on top. If you're raising a power to a power, you multiply the exponents. And if you're raising a fraction to a power, you apply that power to both the top and the bottom, giving you a to the m over b to the m. So here's a few examples. If you're multiplying here, you're going to multiply the coefficients and then deal with the variables. So negative 20. Now the variables are different, so we don't change the exponents. So negative 20 m to the second n to the fifth. Down here, I multiply the coefficients, negative 40. X to the 8, x to the 9 gives me x to the 17. Y to the 6, y to the 5 gives me y to the 11th. If you're raising a power to a power, first of all, you're probably going to want to use a calculator for the most part for something like negative 3 to the 7. The first thing I do when I'm raising a number to a power is I look at the exponent and the negative sign. If I have a negative number raised to a power, whether that power is positive or negative, you look at the whether it's even or odd. If this is odd, then it's going to stay negative. If it's even, then it's going to become positive, because an even number of negatives multiply to give you a positive. In this case, it's going to be negative. And when we take 3 to the 7th power, that's 2,187. 7 3's multiplied together gives you this. When I raise a power to a power, I multiply the exponents. 10 times 7 is 70. Y to the 35. 5 times 7. Over here, 2 to the 10th power. One of the things I see students do all the time, when they're using their fingers to count out, 2 times 2 times 2 times 2, right? 10 2's. And they're doing it in their head. 2 times 2. What I see students do all the time is they go 2 times 2. Well, that's only 1 2. You need to write, you have 2 2's multiplied together. 2 times 2 is 4, 8, 16, 32, 64, 128, 256, 512, 1024. So 1,024, 2 to the 10th. X to the 80, y to the 50. And there is your answer for that one. When you have a fraction like this, remember, as I said before, the bigger number stays where it is and you deal with the other. So in this case, a negative is on the side. That's the same as having it on the top or on the bottom. Only one negative sign. I'm going to leave it on the side in this case. 10 and 3 do not reduce. A to the 6 is bigger, the exponent is bigger on top than on bottom, so A is going to stay on top. And I subtract big minus small, that leaves me with 3. B is bigger on the bottom, and I want my B to have a positive exponent, so big minus small, 6. So negative 10, A to the 3rd over 3B to the 6th power. Over here on the other side, again, 9 and 2 will not reduce, and that 2 is still negative. And if the variables have the exact same power, they cancel each other out if they're the same letter. So x to the 5th cancels with x to the 5th, completely gone, so I don't even have an x in my problem answer. All right, now ignore that stuff to the side. We'll pull that up as we need it. You've all seen these. X to the first means x. X to the second means x times x. X to the third is x times x times x, 3 x's. That's familiar to us. As I go up in my powers, I'm really adding 1 to the exponent each time I move up. 1 becomes a 2, 2 becomes a 3. On the other side, as I go up, I'm multiplying by the base, which in this case is x. So x becomes x times x, becomes x times x times x. Well, if I go the other direction, and by the way, I give credit to Dr. Fandryer at Fitchburg State College for showing me this method. I've used it for the last 26 years. If I go down each time, I am that's going to go over there. I am subtracting 1 from the exponent each time I go down. And on the other side, as I go down, I'm dividing, I'm dividing by x each time I go down here. In fact, I think I'm going to move this, and I'm going to write it this way. Going here, going here. Yeah, it was kind of funky. All right, and that's, didn't mean to do that. There we go. Divide by x each time I go down. All right, now get rid of that. Now if I continue to go down, now I'm getting out of the realm of what I'm used to, which is positive exponents, and now I get into x to the 0. So I'm going to go down by dividing by x. X divided by x, what's that equal? Well, anything divided by itself, with one exception, equals the number 1. So if it's a negative number, like negative 10 to the 0 power, that's still the number 1, positive 1, because it's negative 10 divided by negative 10, 0. Oh, sorry, 1, not 0. Raised to the 0 power is 1. All right. So this is not what I meant to do. This, x to the 0 equals 1. The only exception to this is 0. 0 to the 0 power is undefined. So that's the only exception we have here. Well, if I continue to go down, I get x to the negative 1. Well, I said I'm dividing by 1 each time, by x each time, so 1 over x is dividing by x. There's your value. If I were to continue to go down, x to the negative 2, that's, well, let's think about this. 1 over x divided by x. Isn't that 1 over x times 1 over x? And doesn't that equal 1 over x to the second? Well, it turns out if I go again, I get if I go again, I get x to the negative 3, which is 1 over x to the positive 3. And then I ask, well, what about x to the negative 25? That's just equal to 1 over the positive exponent, 25, x to the 25. So if I want to make an exponent positive, I can just move it to the other side of the fraction bar, no matter which side it's on, and it forces it to become a positive exponent. All right, now let's pay attention to the top here. On top here, I have this problem, and the first thing I'm actually going to do with this, and you don't have to do it this way, but I'm going to show it this way, is I'm going to take anything that's raised to a negative power and put it on the other side of the fraction bar. Now I'm moving those up, and I'm moving this and this down. Everything else will stay where it is. So I've got my 8, my 12, those stay. I'm going to bring up x to the positive 4. I'm going to bring down x to the positive 2. When I move it, it makes the sign change for the exponent. The y is already to the third power on top. I am moving the y on bottom up to be y to the first on top. The z was to the 8th on the bottom, and now I'm moving the z to the negative 4 down to z to positive 4. Now that I've moved all this, now I'm going to go ahead and do my simplification. Now you don't have to do it this way, I just think it's a nice way of keeping track of everything. And it simplifies things. So, I don't know why I did that. Let me erase that. I don't like that. All right, let's continue. So, 8 and 12. 8 and 12 can reduce by 4, 2, 3. I have an x on top, I have an x on bottom. Bigger exponent on top, so x to the 4 minus 2, 2. The y's are both on top, so I multiply and I get y to the 3 plus 1, 4. The z's are both on the bottom, and so when I say 8 plus 4 rather, that's 12. So there is my answer, 2x to the second y to the fourth over 3z to the 12. There we go. Now I want to take a look at these two. Anything to the 0 power becomes a 1, and if there's other things around it, you can just cross that off. It becomes the number 1. Not to the first power, the number 1. 10 and 4 reduce, 5, negative, didn't go away, 2. And then the y to the second is still on top, the x to the third is on bottom. Now, a lot of people will say, wait a minute, I see a negative, we want to make that positive, move it to the other side of the fraction bar. Does not work that way. This is a negative number, not a negative power, so we are going to leave it just as it is. Over here, I'm going to have the 2 and the negative 5. Now, I want to show you, there is another way to approach this. You don't have to move the y to the 3 power on the bottom. You can. X's to the third, that's going to cancel out completely to 1's. And I'm going to have y to the 13 on bottom. Now, we could move this down to y to the positive 3 and then add them. There's another thing that you could think about that as. The bigger number is the 10. So 10 minus, division, subtract. Bigger number minus smaller, minus negative 3. Well, what's 10 minus negative 3? Isn't that the same as saying 10 plus positive 3? So therefore, the bottom is going to be y to the 13th power. So that's another way you can look at it. You don't have to. You can bring that y down, have it to a positive, then add them. All right, here's a couple of multiplication problems. If we do these out, again, we're multiplying. Now, this is just like before, so this was really not the greatest example, but 40x to the 5 and 8 is 13, y to the 5. That didn't really do us much good, because we've already done those. This is a 1, so that we don't have to worry about. Now, when I have problems like this, sometimes I move it down, so if it's a complicated problem. This is pretty simple. I'm going to actually multiply first and then change if it's a negative exponent when I'm done. because we are allowed to add negative exponents, negative numbers. 4 times negative 1 is negative 4. M to the first times m to the negative 2, that I add my exponents and it's a negative 1. Well, that's the same as saying negative 4 over m to the first, or just m. And there's my final answer. No negative exponents. All right, let's take a look. Make sure I didn't have anything under there. Good. Let's take a look at our next examples. If I have something like this, I can rearrange this so I only have positive exponents. That's the first way I'm going to do it. So I can put it over 1, and so now I have x to the 7 over y to the positive 2 raised to the negative 7 power. Now, if you don't want to deal with a negative power on the outside, the way you can get around that is to change that negative 7 on the outside to a positive 7 before you apply it. Just flip over the fraction. Y to the second, x to the 7 has now flipped. It's the reciprocal. Now that I've done that, why do I do that? I think an arrow would be sufficient. I don't need a double line arrow. I apply the power to both, so this gives me y to the 14 over x to the 49. Now I want to show you, you can do that directly from what you have here. Instead of changing it all and flipping, just apply the negative power. Negative 7 times 7, x to the negative 49. Negative 7 times negative 2, y to the positive 14. I'm going to move the x to the negative 49 down to make it a positive exponent, and there's my answer. So sometimes it's a little easier to do it that way. All right, I take a look at this. Everything in that parenthesis is raised to the 0 power. So the whole thing is just 1. All done. If the whole thing is raised to the 0 power, your answer is just 1. Now give this one a try, see what you can do with it. Remember, you should probably simplify the denominator before you try to reduce the fraction with division, but it's not required that you do it that way. You could cancel things out as you go along. It's up to you. Give it a try, unpause, and then see how you did. All right, so I'm going to say negative 10. I'm going to cross off the things that are to the 0 power. I've got y to the 9 on top, 9. I'm going to multiply the bottom together. Negative 1 times negative 10 is 10. X to the negative 4, x to the negative 2, that makes x to the negative 6. And then y to the 9. I can move that negative 6 to the top right now. In fact, I can do that x to the positive 6 because there's no other x's in here. So that just becomes x to the positive 6. Y to the 9s are going to completely cancel out. And negative 10 over positive 10, I'm just going to have negative 1. Isn't that just negative x to the 6? And that's my whole problem. That's my whole answer. Negative x to the 6. All done. Notice there's a difference, by the way, between negative x to the 6 and negative x to the 6 in parentheses being squared. In fact, if I have negative 10 squared, that's equal to negative 100. A lot of people think it's positive. It's not. The only way you have that happen is if you square, that's a square, positive 100, because it's negative 10 times negative 10. This power happens before you apply the negative. Think of it this way. 1 minus 10 squared is 1 minus 100, or negative 99, right? So that's something you can just think about as to why it works the way it does. All right. Besides, it's order of operations. In this problem, I'm going to do the power on top before I do any division. So let's do that. This is a -1, and it doesn't matter whether this is positive or negative. It's even or odd applies to the negative part. A negative number raised to an even power becomes a positive number. A to the positive 50, b to the -60 over -1a. Well, I'm going to move this down, and I'm going to reduce these two. Now that is a -1 coefficient. I can move that anywhere I want it, up or down. I'm just going to leave it where it is. I'm bringing this down, so that's b to the 60. And when I simplify this, 50 minus 1, a to the 49. And there's my final answer for that problem. Let's just separate these. All right. That's going to be a 1, so I don't have to worry about that. I'm going to apply the -9 power. U to the -4, V to the -9. I've got a negative V to the -36. Let's move all of the negative powers around so that we only have positive powers. V to the +36, U to the +4, V to the +9. I still have a negative there. The 36 is bigger than the 9 for V, so I'm going to subtract V to the 27. I still have a negative, U to the 4, and there's my final answer. In this problem, that's a 1, right? I'm going to apply the 7 power, -m to the 3rd times. A negative raised to an odd power is still negative. M to the -14, N to the 63. And then multiply, negative times negative is positive. M to the -11, N to the 63. Now I'm going to throw that over 1 because I want that negative to be a positive exponent, so I'm going to move it down. N to the 63 over M to the 11. And there you have your final answer. All right, this one has division, power, and multiplication all in the same problem. So will the next one. I'm going to do the power first, then the multiply, and divide. So, let's see. I've got a negative. I'm going to put the negative on top just to make it simple. Y to the 6. Now, when I raise x to the 4, raised to the 3rd, that's x to the 4 times 3, 12. All right. Final answer. Please notice, the y is going to be on the bottom, 10 and 6, because 10's bigger, so it's be a 4. That leaves nothing on the top. So when I cancel this out, it actually will become a -1. The 1 from canceling this out with this, and that leaves me with the 1, and the negative was there before. X to the 12 plus 4, 16. So -1 over x to the 16, y to the 4 is my answer here. I think this is the last one for today. All right, wow, that is quite the problem. What I'd like to do is I'd like to simplify all of the inside before I bother to apply the 4 on the outside. That'll make our life a lot easier if we do that simplification first. So, negative times negative is positive. X to the 3rd times x to the 4th is x to the 7. Y to the 14, x to the 10 on bottom, y to the -6. All raised to the 4. Now I can bring that negative 6 up first, which is not a bad idea. So x to the, in fact, why don't we do all the reducing at once? If I bring this up, that's going to be a positive 6 on top. So when I add them, y to the 20, because it's multiplication, I add exponents. The x to the 7 and x to the 10, I'm going to have subtraction, x to the 3rd on bottom. All right. I finish this off by raising each of these to the power, y to the 80 over x to the 12. And there's your final answer. So I hope the negative and 0 exponents haven't thrown you for a loop, and that you're following the process of doing the simplification of things to a power. Have a great day.